What is going on, fellow web developers? My name is Tyler Potts, and today we are going to be making a bouncy ball simulation, what you can see on screen. Now this is using random, basically a random colours, velocity, sizes for each ball, and we can just keep refreshing and get a random result every time. And I'm going to show you how basically you can make this simulation in JavaScript using the canvas. So the first thing we're going to do is I have a little folder here, and it has something called tutorial and main.js. Now in here, I have a basic document. As you can see here, I just have a title. I have a style, resetting some sizes, and also setting the canvas to display block, and just setting a default background color so we don't have to do it in the canvas. And then I've got a canvas, just literally a canvas element, and a reference to a main.js script, which in this script has literally nothing. As you can see here, it is just an empty an empty thing with a helper function. Now this helper function just gives us a random integer. So if we was to call random between 0 and 10, this is just going to return a random number between 0 or 10. Literally that. It can either give us 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, or 10. And it's an integer, so it will just be whole numbers and not floats. We also want a random float as well. And to do that, we're just going to remove the floor on the whole thing. This will give us just a random float because we're going to need that as well. Alright guys, so the first thing we're going to do is literally get a reference to our canvas, which we're going to set to documents.querySelector, and I'm just going to say canvas. I then want to create, or actually even above this, I want to create some options, which is going to be set just basically, just going to have our default width, which is going to be window.innerWidth. And then we're also going to get the height here as well. So we'll just trade these out to say height like that. And I'll just trade this H to be a capital H to actually fix that error there. And then we want to get the context, which I'm just going to label as CTX, which is going to be the canvas.getContext. And we're going to get context of 2D. Now, once we've got this, we can technically get started. Now, I'm going to create some functions, one called setup, which is where we're going to do all these setups. So I'm going to set the canvas.width equal to options.width here. I'm then going to get the canvas.height and set that to options.height here. I'm also then going to run this. We're going to cd into the tutorial, and I'm just going to say npx serve dots. Now, you might not have Node installed or npm installed. If you don't, you can easily just open up the file by double clicking on the HTML file in your Finder or whatever else you are using. So now if we refresh, you're going to see we just have a blank canvas. And to actually get this to work, we're going to create a little thing here, and we're going to call this the events. And we're just going to say window.addEventListener load, which we're just going to call the setup function. So on load, this will now take our full screen size just to match it basically. Now there is a few other options we're going to have. We're going to have an update function. So this is where we're going to do all our physics calculations and stuff like that. And then we're also going to have a draw function, and this is just going to be where we draw everything to the screen. Under this, we're going to have one final function, which we are going to call loop. Now the loop function is going to be essentially just what is called over and over again. And in here, we're going to call update. So we're going to say update, draw. And if you saw in my last one, there was an FPS counter up there, which I had a debug function as well. I'm not going to do that for this one, but I just thought I'd mention it because people probably ask where it is. And if you want to see that, I'll show you at the end how I actually did the debug. But right now, we're going to focus on the actual thing. Now, to actually call this function and to get it to run in a loop, which is going to do, obviously, the next frame, we're going to do request animation frame. Now, this will call this function as many times as it needs to call itself to actually, basically, it's going to call it a bunch of different times per frame or per second, which is going to be each frame of this game. This will basically give us our infinite loop. Now, inside of our setup, we're actually going to copy this, and we're going to call this because we actually need to initialize this loop. And just to prove it's working, let's just log draw in here, where we can just press F12 refresh the screen, and you're going to see it says draw over and over again. This is how many frames are being called right now. So refresh that. We can delete the draw function there, and that is basically the game loop ready to go. Now, one thing we want to notice is every time we draw to this screen, it's going to draw a over and over again, and it's not going to delete the last frame it draw. So to delete the last frame, we want to say .clearrect, ctx.clearrect, and we're going to set its position to be at the top the top left of the screen, and then we're going to use the canvas.width and the canvas.height to actually clear the whole page, so we can actually run our simulation, not have basically drawing lines rather than something else. I'll show you what happens when we remove this later, once we have the balls moving around the screen. So we now have a bunch of different elements, or basically we have our draw setup all ready to go. Now we want to create a ball. Now we could just create multiple balls and run all of their functions in here, right here, all in here. So if we had loads of balls, we could just say each ball just adds like the speed and all of that in here. But we're going to use a bit more of an object-oriented approach, and I'm going to create a class just at the bottom in here. And I'm just going to say class. Now, normally I'd put this in a different file, but for this basically simple constructor here, or simple lesson, I'm going to do it all in one file. Now, you can split all of this off into separate files. Normally, I put my helper functions down in a separate file, but I thought it'd be a bit easier for you guys to understand by doing it this way. Now, in our construction, we want to get the ball's X position. So this way, it's going to be placed in the canvas. Its Y position. We want to get the size of the actual ball, so how wide we want the diameter of the ball, basically. We then want the velocity X and the velocity Y. So this is going to be the speed the ball is moving at. And finally, we're going to have the color. Yes, I'm using the English spelling because I am from England. So I'm going to be using that. So apologies. You can take the U out if you want. This is just what I want to do. Anyway, we're going to say this.x, this.y is equal to y. So we're just going to set up some variables to start this off. So we're going to say this.radius is equal to the size divided by 2. Now, inside of Canvas, we create arcs, and the arcs go in radius, which is half of a circle, for example, the width of a circle. So that's why we're getting the full size and divide it by 2 to get the radius. We're then going to get the this dot velocity x is equal to the velocity x, and this dot velocity y is equal to velocity y. Now we could do all our random, randomness inside of here. So I could set this to be a random integer between the canvas width and the canvas height. Same with all of this, but we kind of just want it to be, we basically want it to, we're going to do it outside of here. So if we want to set some predefined sizes, we can. Now we've got all of our constructions. Oh, we actually missed this dot color, sorry. So I'm going to say this dot color is equal to color. Now, once we have this, I want to go down and create an update function for this. Now, this update function, basically, is going to be our ball update function. This is where we're going to do all the logic for our ball. But we'll come back to this in a moment. So we're going to say logic. We're now just going to create a draw function, and we're going to pass in the CTX. Now, this is the context to obviously our canvas. We need this to actually be able to draw. And then we're going to say ctx.begin path. So we're just going to open a new path. We're then going to draw an arc. So we're going to say arc. And we're going to say this.x, this.y, this.radius. So you can see up here, the canvas path arc requires an x, y, radius, start angle, which is going to be 0. The end angle, which is going to be math.pi times 2. And then counterclockwise, we're going to set to true, because so it comes round this way. To be fair, it doesn't actually matter, I don't think. I think we can do it either way. But yeah. So now we're going to set this to 0, and then this to math.pi times 2. And we can set this to true. And then we can close our path. So let's just do ctx.close path like this. And then we then need to actually give it a color. So we're going to say our ctx.fill style is equal to this.color. Then going to say ctx.fill to actually fill in our arc. Now let's actually try just drawing a ball on the screen. So what we want to do is come up to our setup, or actually up here, let's just create a let ball like this. And then we want to define our ball by saying ball is equal to a new ball, which is going to take an X. We're going to say, let's say 100, 100. The size will be 50. The velocity will be 0, 0. And the color, we can do it as white for now. Then we just want to go down to our draw function and say ball dot draw. And you can see nothing is happening, because we have an error with begin path. And the reason for this is because we actually forgot to pass through the CTX to our draw function. And there you go, that's now working. You see our ball is on the screen. We can move it around. Let's make it like 200 by 100. And there you go, you can see that's moving around nicely. But now how do we get this ball to move around and bounce off the walls? Well, the first thing we want to do is actually get this to move. So in our logic, we just want to say this dot x is plus equal to this dot velocity x, and this dot vy is plus equal to this dot velocity y. This is going to actually make our ball move around, and then every time we redraw it, it will move it across. So let's go back up to our ball and give this a velocity of 1 and let's say 0.5. And then inside of our update function, we're just going to copy this, paste this, and say update, and remove the CTX for that one. And now you can see the ball is moving across our screen. Now remember earlier I cleared the canvas. You're going to see that goes off screen. We're going to fix that in a minute. But remember earlier I added this clear rect. If we remove this, save, and do this, you'll see the ball is not being deleted after it's moved. So it's just drawing a line across the screen. So we want to return the CTX clear path. And there you go. Okay, so in our update function, we want to make sure when this hits the edge of the screen, it bounces back. Now to do that, we can just do a if statement and say this dot x minus this dot radius. Actually, I'm going to show you without radius first. So we're going to say if the x position is less than 0 or the x position is greater than options dot width. So there's the width of our obviously page. We're going to say this dot vx is times equal to -1. This will flip it to a whatever the opposite value is. Now we can copy this and do another one here. Say this dot y or this dot x and then y. And we basically do the same thing. We just need to change this to the height as well. And now if we press play, you're going to see the ball is going to go all the way over here. I should have made this a bit faster. It's going to bounce off that wall. But did you notice it actually goes into the wall? So it's actually gone inside this instead of coming out. So you can see it's just same there. And then off the bottom there as well, you can see. Now this is where the radius comes in. So we actually want to come here and say minus this dot radius. And we can do this for both the x and the y. And then on this one, we actually want to plus it because it's going in the opposite direction. There we go. We can make this look a bit neater just by dropping this down, dropping that down, and just breaking that down there. Got to keep the code looking neat. That way it will just be easy to read. And now if we play, you're going to see, and actually let's just speed this up to be like 2 and 2. There you go. So now you can see when it hits the side, it's going to bounce straight off here and bounce around. And there you go. That's technically all you have to do to actually make a bouncing ball. But how do you actually add in the randomness to this? And also the ability to have multiple balls. Well, let's do the multiple balls first. So the first thing we're going to do is go balls, and we're going to set this equal to be an array. We're then going to come here and say balls dot push. And I can just push a new ball to this. And then instead of this, we just want to change this. And we want to say for let ball of balls. And then we're just going to call update. We can do a similar thing down here, but we're just going to put this in here. And now we refresh. You can see it's going to do the exact same thing. Now we can copy this and paste it and change this to, let's say, 600 and 300. The size can be 80 and the velocity can be -1 and 1. And we can make this a reddish color, so it's a FF2424, something like that. And And there you go, you see we've got another ball slightly slower moving in a different direction. Now this is good, but now we want to add make them random, so they actually bounce around randomly, and also we want the ability to add many balls as well. So the first thing, we'll say ball count is equal to, and we can set any number here, so we're going to say ball count is equal to 10. This can also be a constant because this will not change. And then down here we can say, okay, well, let's just delete that comment now. We can say for let I equal 0, I is less than ball count minus 1. Oh no, ball count, sorry. And then we can say I plus plus. Now in here, all we want to do is we want to get basically a bunch of different random stuff, and this is where our helper functions come out. In this helper function, all we do is get a random in or a random float. This is inclusive and exclusive of the min and max. So in here, we want to say let random size equal random, and we can use an int for this one, and we're going to say random size between 20 and let's say 100. And then up here we can bring the balls in, and we can push a new ball with the random size. So let's just come in here, take this and pass it into our size parameter. Then let's just do a random x quickly. So we'll say let rand x equal to, and this is actually going to do a random float between 0 plus the random size divided by 2. So we need to get the radius, because if you remember, it will be halfway off the page if not. And the options dot width minus random size divided by 2. So it's going to get us from either this point here to this point over here. And we can pass in the random x. And then we can also copy this. We can change this to our y. And this can practically say the same. The only thing that needs to change is this. And also I've missed an e at the end of our function there. Now if we refresh, you can see we get a random. Well, the y isn't so random. That's because we're not actually passing it in. That's my bad. There you go. You can see we get a random position each time we refresh for different balls. Now let's get a random velocity. This one is quite simple. All we do is just say let rand vx equal random float between, and we're going to say -1 and 1. And then we can also do the same with our random y value here. Pass this in, and I'm just going to paste the same thing and delete and replace with y. And now you can see we're going to get balls that move at different speeds. Whoa, that looked kind of cool. And go at different angles. Now the final thing to do is actually get a random color. Now to do this, I'm going to say random color, and we're going to say equal to, and I'm going to use RGB here, and I'm going to add in, we're going to basically use a concatenated string and say random int, and we're going to get a random integer between 0 and 255. Now we need to do this 3 times. Let's just copy this. And now, we need to actually pass in our random color. And there you go. You're going to see we get a random color every time we refresh. And there you go. That's how you do all the random balls and bouncing around. Now we can up this to something like 100. We can up this to so crazy like 1,000. But once we start going any higher, let's say 5,000, you can see everything looks really slow, and that's because the frame rate is becoming extremely low. Now, how do we show the frame rate in this? So earlier I said I was going to show you how to add the frame rate in. Now to do that, I'm just going to show you from our main tutorial here. Scroll down and we have this debug here. So let's copy this, bring it back into the tutorial. I'm going to paste this down here. Now you can see here, our debug takes a timestamp, which we will get from our loop here. And and you can see here, all it does is display our frames per second, which is our seconds passed minus our last timestamp divided by 1,000. So let's actually add this in. I'm going to just uncomment this, and we need to pass in the time, or we can just pass now. And this loop actually gets a now from the request animation frame. This is going to be the timestamp we use. We also need to get last timestamp as a variable up here. So let last timestamp equal nothing. And there you go. You can see our frame rate up there. Now, if we go back and we up the count to, let's say, 2000, you can see our frame rate is significantly lower. And if we go even higher, like 5000, you can see it goes down below the 30s. And now I'm going to do something that may blow my PC, but we can go 10,000, and you can see how much slower that is. 15 frames. If I had one more 0 to this, yeah, the whole, look, we're getting 1 frame per second. Let's drop that down back to something which is manageable, like 167 frames. 100 balls. There you go. So that is how you create a random bouncy ball simulator inside of JavaScript. Thank you for watching this video. Don't forget to like, subscribe, and I will see you in the next one. Peace out.